All right, going to be doing the problems here for 3.4, library of functions. Let me see if I can make this a little bit bigger. There we go. All right, that should work. Okay, so first thing here is it says that f of x is defined as follows. And for part A, B, and C, what they're asking us to do is evaluate the function at different points. So for the first one, f of -4, I need to look at -4. That's what I'm plugging in. And I need to figure out whether or not it goes here, here, or here. So I ask myself, is -4 less than 0? Well, yes, it is. So I'm going to use this part of the function. If I check here, -4 is definitely not equal to 0, and -4 is definitely not greater than 0. So it's only going to work in one of these pieces, but I wanted to just show you that it did not work in these. So I plug -4 in here. So f of -4 is going to be that -4, but squared. That's what it says to do. And that's 16. So our answer here should be 16. And we move on. Okay, so for the next one, we want to plug in 0. Well, obviously, when we plug in 0, 0 is equal to 0. So we're going to use this. And that 3, really, the input doesn't matter. No matter what we plug in, it's going to spit out 3. So we just plug 3 in. Boom. Okay, and then last one is to plug in 4. So they want us to plug in 4 here. So 4 is bigger than 0, so we'll use this one. So I'll plug 4 into there. So f of 4 is going to be, let's see, 3 times 4 plus 3. That's 12 plus 3. That should be 15. And that is it. Okay, next one. Have another piecewise function, has 2 pieces, and we want to evaluate it at some different values. So I'm going to try and do these all at one time. So let's do f of 0 first. F of 0, well, 0 is between -2 and +3, so I'm going to plug it into this one. So 2 times 0 minus 4, that's going to be -4. If we do part B, which is f of 1, well, 1 is also between here, between these two numbers. So I'll plug it into the top piece of the function, plugging in 1. I get 2 times 1 minus 4, that's 2 minus 4 is -2. All right, part C, we're going to plug in 3. So let's see. In the top one, 3 is less than or equal to 3. So I want to stay in the top one here. You can see if you plug in 3 here, 3 is greater than 3. So I'm sorry, 3 is not greater than 3. 3 is 3. So it can't be this. So 2 times 3 minus 4, that's 6 minus 4 is 2. And then finally, f of 6. Now finally, 6 is in here. 6 is less than or equal to 6. So I'm going to plug in 6 cubed, take away 3. And I don't even know what 6 cubed is. It's 36 times 6, 180, 216, I believe. Yeah, 216. So 216, take away 3, it's 213. Okay, here we go. Let's put these answers in. -4. Next one is -2. Next one is 2. And the last one is 213. All right. Okay, so now for this piecewise function, it says to first find the domain of the function. So looks like this function is only defined, we go from -2 to 1, and then include -2, don't include 1, but here we will include 1, and then we will include everything past 1. So if I look at this like on a number line, the domain of this is going to start at -2, include -2, go all the way till I get to 1, not include 1, but then on this piece, I will include 1, and then the next piece says 1 and on. So forever that way. So that's basically from -2 to infinity. They want this in interval notation. So I'm going to put a bracket, -2, comma, then go to infinity with a parenthesis. Okay, next part, clear this out. Okay, so next part, locate any intercepts of this function. Okay, and so I think this would be a good opportunity for us to try and graph this. So I'm going to have to do this on a separate page here. Oops, I actually don't want that in there. Okay, so let me try and graph this. So the way I'm going to graph this is make this a little smaller. Okay, so here's my graph. Give me a moment to bring a decent looking graph in here. And I think I want to make my, just keep it. Okay, so let's do this first piece, x plus 3. Now we need to know that this is a line, has a slope of 1, and a y-intercept of 3. That's using the fact that it looks like y equals mx plus b. M is the number in front of x, the y-intercept is 0. So if I were graphing this whole line, I would go to a y-intercept of 3, 1, 2, 3. I would put a dot here. Then it would have a slope of 1, so that means up 1, over 1. And then I would draw a straight line connecting these together like this. Okay. But I only want to go between -2 and 1. So if I go to 1, it's going to stop here. So I'm going to draw this one in blue. It's going to stop here and not include that point because it's an open circle because of the inequality there. And then at -2, if we plug in -2 into this, we get 1. So at -2, we should be at 1, which is exactly what we see there. And it's just the line segment between there. Okay, now erase all that. That's the first piece. Now the next piece is right here at 5. So at 5, I'm sorry, at 1, we're 5. So at 1, we go up 1, 2, 3, 4, 5. We're solid dot here. And then the last piece is this. So this is a line again. It has a slope. I'm going to put m, -1, and it has a y-intercept of 2. So if I go up 2, 1, 2, it has a slope of -1. So down 1, over 1. I would have a line that goes through like this. But I only want this line when I'm greater than 1. So that means I'm going to do it in a different color. That means if I start here at 1, I don't include that point. And then I go this direction down here like this. Like that. And let me erase the other piece. So there we go. There is our piecewise function drawn. Now let's go back to the question. Find the x-intercepts. So we can see we have one x-intercept, and it happens when this line hits the x-axis. So if I were to take this piece, set it equal to 0, I could just add x to both sides. I get 2 as x. So we should have an x-intercept there. And then the y-intercept is here. And that's what we get when we plug 0 into the function. And when we plug in 0, we're in this top function. And when you plug 0 into this, you get 3. So that corresponds to that point 3. So y equals 3. So I think they're going to want them as points. So this is going to be the point 2, 0, and this is going to be the point 0, 3. Let's go ahead and go do that. 2, 0, and 0, 3. Right as an order pair. So 2, 0, and 0, 3. Okay. All right, so we've already drawn the function, but they want us to pick out which one it is, and it was this one right here. Okay, based on the graph, find the range of the function. Okay, so if we go back to our graph, the range are the y values that come out. This is a little bit tricky because if we start looking down here, okay, it goes forever that way. So I know that my range is going to be down to -infinity. And then as I come up, I have graph, I still have graph. Now, when we get right here, it's interesting because if you look across, even though that's an open circle, we do hit here. So we still have graph all the way till we get up to here. And then once we get here, we don't have graph right there because of that circle. So that looks like a y value of 4. So it looks like we're going to go from -infinity to 4. And then we have one more output, nothing between here. There's nothing in between right in this little gap right there. But we do take on this value here of 5. So that's a single 0.5. I'm curious to see how they're going to want us to write that. But that would be the range, -infinity to 4. And then we have the output of 5. Really curious to see how they're going to want us to put this in. Okay, so here we go. The range has at least one isolated value. It can be expressed as the union of the interval. So the interval was -infinity to 4. And then the set, it was just 1.1 value, 5. Check it. All right, good. They let us, I was curious how they're going to want us to do that. Okay, this is going to be another problem like this. So why don't we just start with the graph? Just start with the graph. So as before, I'm going to graph this thing. Okay, so the first piece here, we rewrite it as 2x plus 4. It has a slope of, it's a line, it has a slope of 4 and it has a y-intercept, sorry, a slope of 2 and a y-intercept of 4. So maybe I need some smaller squares here. Let's do that. So if I go to graph this, it's going to be y-intercept of 4. So 1, 2, 3, 4. Here's 4. Should have a y-intercept there. And then a slope of 2. So up 2 over 1. Up 2 over 1. So if I connect a straight line between these two, or between those points, we should get something like this. This line. But we only want this picture if we are less than 0. So if we go to 0, we have to put an open circle there. I'm going to do it in blue. And then it's just going to be this piece over here like that. Let me erase the red part there. So that's the first part of our graph. The other part of our graph is one of our library functions, x squared. We know that x squared looks like this. But we only want it to the right of 0. So we don't want this left side, and we actually do want to include that point as a solid dot because we have the little equals underneath there. So that's the graph of our function. Now let's go answer some questions. So first of all, the domain of the function. So if we look back at the graph, to the left we have picture, to the right we have picture at 0. We do have a dot here, so it should be all real numbers for our domain. So they want interval notation, so -infinity to infinity. Oops. What was the keystroke again? It was back in, yeah, -infinity to, again. There we go. Okay, how about any intercepts? You should be able to tell by our graph. Okay, we have an intercept here that happens at -2. We also have another one here at 0. And y-intercepts, the only y-intercept we have is also that point. So our two intercepts are -2, 0 and 0, 0. Right? 0, 0, -2, 0. So 0, 0 and -2, 0. All right, which graph is the correct one? Let me see. It's this one right here. Yeah, it was that one. Okay, the range. So the range, you know, it goes down forever. And then as we come up, the only interesting points are really, let's see, right here, we have graph. Here, even though we have a circle, we have graph over here. So we've got everything. So it looks like all real numbers, everything. The range consists of exclusively one or more isolated values. No, it's going to be this. No isolated values. No. Oh, here we go. No isolated values. Here we go. Just interval. Negative infinity to infinity. Okay. All right. Absolute value. All right. This is going to be another interesting one here. Graph this guy. Sorry about the background noise. I'm at work now, so people are chit-chatting instead of working. I'm kidding. Let them have fun. Okay, so let's start with the x cubed, because I think that's the easier one. X cubed looks like this. But we only want the right side because of the greater than or equal to 0. So I'll get rid of the left side, and I do want to include that point there. Okay, now the other one is the absolute value of 2x. So I think what would be best here, we only want to look between -3 and 0. Let's just plug in -3 and see what happens. So if we plug in -3, 2 times -3 is -6, and then we take the absolute value of that, we get 6. So we go up 1, 2, 3, 4, 5, 6, put a point. And then if we plug in, let's say -2, we're going to get -4 in here, and then the absolute value of that would be 4. So we go up 1, 2, 3, 4. And if we plug in -1, we get 2. I'm not going to show that. But what we do need to know is that absolute value functions, they look like V's. So we know that this is going to look like a straight line like this. And it comes and it stops at 0. So there should be an open hole there, but that x cubed fills that hole in. So everything's nice and solid. So the domain of this is everything. Let's talk about it before we go answer questions. The domain of this is -infinity to infinity. The only intercept we have is at 0, 0. The range of this is only starts at 0 and up. So it goes from 0 to infinity. Let's see if that's what they're going to ask us. I didn't even look. So domain is -infinity to infinity. What? Oh, I'm sorry. Look at, they start at -3. I apologize. They start at -3. I forgot. On my graph, let me go back to my graph. I needed to stop that there. My fault. Yeah, because of this right here, they want us to stop. So -3, that changes our domain to -3 to infinity, including -3. Doesn't change our x-intercept, doesn't change our range, because this side keeps going up forever. All right, so -3. Come on, won't let me edit that or what? -3, and I want a bracket on that. The only intercept is 0, 0. Oh, and the correct graph. So it's like a straight line with it going up, straight line with it going up, this one. Range, it was bracket 0. So it went from 0 to infinity. Oh no, I'm in the wrong section. Hold on, I clicked on the wrong one. There, this one. No isolated values, so 0, infinity. Okay. All right. The graph of a piecewise function is given. Write the definition of the function that best describes this. Oh wow. Let me copy this. This one's tricky. Didn't really plan on covering this in class, so maybe I'll need to. So they give us this function. Okay, so let's take a look at it. It looks like it's two pieces. So our function is going to have two pieces to it. First piece starts here. It looks like that's -1, -2, starts at -3. It's got a dot here, so it's less than or equal to x, and then it stops here at 0, and it does not include 0 because it has an open hole up there. The next piece starts at 0 and includes 0, so 0 less than or equal to x, and then it goes all the way till we get to look 7, and it keeps going forever. So just x is greater than 0. That's fine. We can just do that. Now, this right here is a line, and so all we need to know is the slope and the y-intercept. So the slope, to get from one point to another, we have to go up 1, 2, and over 2. So up 2 over 2. So that's 1. 2 over 2 is 1. So this should just be 1x plus the y-intercept, which is 1, 2. If this line continued, it would hit at 3. So we put 3 there. Now this line has the same slope, up 1, 2 over 1, 2. So it has the same slope plus the y-intercept on this one. It hits the y-axis at 0, so x plus 0, which I can just put as x. So there it is, x plus 3 between -3 and 0. Let's see if I can get this up here. Okay, so it's x plus 3. If we go from -3 to 0, not including it, and just x if x is greater than or equal to 0. Did I put equal to 0? Yeah, I did. Okay, I didn't remember putting that. That should be it. All right, this one. All right, I'm gonna have to, all right, let's just read through this. In March 2014, a gas company had the rate schedule shown to the right for natural gas usage in a single family residence. Let me go do this on a different page and then we'll come back and answer everything. Okay, so this is the charges. And they want to know, what is a charge for using 30 therms in a month? A therm is a measurement of how much electricity. So let's understand what's going on here. Every month we get charged $20.35 no matter what, just to have service. So that's what we call a fixed cost. So the cost will be equal to, no matter what, $20.35, okay? Plus now, let's let X be equal to the number of therms that we use, all right? So we are going to get charged for the first 40 therms. This is how much we're going to get charged per therm. So I'm going to put here 0.86755 times X. And that's how much we get charged if X is greater than or equal to 0, but less than or equal to 40. Okay. Oh, I've got a student here. I'm going to have to go and leave this one to you. Let's do that. Let's leave this one to you. I think this is a good bonus question. So yeah, sorry.